Now, I want to introduce Brahm Verma, who will give us some reflections on what he has heard and both before today as well as today about the tasks ahead that we're challenged with. Brahm is a professor and associate director emeritus from the College of Engineering of Georgia, and he's the founding president of the Institute of Biological Engineering, one of our sponsors today. Brahm?
Thank you, Jim. Can you see my slide?
It's not in full presentation, but now, yeah, that's good.
All right. Well, I have this very envious task of recapping and reflecting on the issues that are presented today. First, let me commend the National Academy of Engineering for initiating this focus initiative, and then selecting food and agriculture system as the inaugural topic to discuss, which is obviously, to me, one of the most important things that a civilization has to address. So let me thank you for this opportunity. What I will do in this time is to, as a reflection, would look back a little bit, look at now, and look forward. And I will try to connect with some of the comments that were made by speakers that have gone before. So looking back, it has been repeatedly said of the great contributions and the achievements of the food and agriculture system, and the amazing supply chain from pre-production to consumer that not only provides food, but feed and fiber and materials for energy and other things, including pharmaceuticals. It is essentially the core of life and the essence of our civilization. What is important for me to recognize here is that it is a complex system. And this has been said several times, but perhaps not in this way. A complex system is a system of systems in which patterns of relationships connect subsystems to build interdependencies. So this is an important concept, and this concept is not quite always fully appreciated. Food systems are sustainable to a degree because they are connected with natural systems and social and economic systems. No system can be sustained in its independence. So any actions taken in food system affect natural and social systems and vice versa. And therefore, for this reason, food systems are essentially everybody's business. But that is currently not the case. Now, how did we get here? We talked about linear systems. We have come to this point by responding to questions that arise from Cartesian reductionist mindset. What that means is, when we are solving a problem for a system of immediate interest, we usually do not give enough consideration to those systems that are connected to them. And consequently, there are unintended consequences, what one could consider as collateral damages. So current overall linear economy that we have, linear food system is a part of that, comes from this kind of questioning, where it is always a dominant question as to whether we increase productivity or reduce pollution, or whether we increase profitability or reduce greenhouse gas emissions. Unless there are solutions to it, obviously we'd have to deal with the trade-offs. But we have to pay considerable more attention to having the or to convert into and. So as a result of this, these linear systems that we have are highly productive, but they also use a lot of resources and they produce a lot of waste. They are not sustainable, especially with the increasing need for the food system. So let me take a minute to look forward for a minute. And I created this phrase to convey the central thought that I have. What we need is the collective power of imagination to broadly adapt circularity as a strategic objective or goal to create ecology of complex unifiable food and agriculture systems in which subsystems are connected to build interdependencies. Questions arise from contextual and process thinking, and solutions align with nature's sustainability. There is a lot in that statement, and that I would try to unpack it a little bit here. So we know natural systems are more sustainable, and the reason for that is that the processes within all of those subsystems contribute to circularity. Waste of one system becomes food for the other systems. This means food and socioeconomic systems, in food and socioeconomic systems, all processes that we think of or designing should be designed towards the goal of making them more circular. That is the only way to move towards greater overall circularity. What this means is that we perhaps should think about designing cyclic process fractals. And these fractals then become the component that can be unified to achieve towards greater overall circularity. And this can be only measured if we would spend time and our creativity in developing performance metrics to be able to measure these things. There's somebody, okay. So this is really, to me, a very important concept to bring that. In that context, what has been already talked about is the convergence of perspectives. I think of convergence itself as a complex system because it brings people together, interconnects them, and builds dependencies through which ideas emerge just as emergence takes place in ecosystems. For that, obviously, we need universities and professional societies to break their barriers. We need the producers and the processors to become actively engaged. Perhaps the National Academy of Engineering can be a catalyst in incorporating circularity, in promoting incorporating circularity as a required objective for the engineering design for all projects. Engaging public is another important component. Citizen science has been used, and I think we can consider a bit more as to how we can engage that. Sometimes simple science at right places can convey profound messages. This is a message that simply says in a restaurant that yesterday we wasted 45 kilograms of food that could have fed 180 people. Imagine the potential educational opportunity such science would have to communicate with citizens and engage them. So lastly, I want to just briefly touch upon and quickly about the potentials of alternative ways of producing food. Vertical farming, controlled environment systems provide opportunities that are not available otherwise. They have the potential of creating plant factories and as a part of the food and agriculture system, they could provide particular types of products that are suitable for this kind of environment. The other part that is very interesting to me, and it's a slide I made a number of years ago, convergence at the bottom, convergence of the atom, the gene, and the bite at the bottom has the potential to create things that we have not imagined the way to do it. The best experience we have so far is with the nanotechnology, which dealt largely with atoms. But there are possibilities of converging these at the very basic level by which we can create products, even biomaterial products, living products. And Eric talked about that, about their work in upside foods. This is not a trivial opportunity, especially for the food systems that would be needing so much greater supply. They tend to be using a lot less resources, and they're a lot more controllable. They need a lot less land, less water, less resources. They have the potential of reducing the distance and time from farm to fork. And they have also potential, especially for those regions of the world where people yearn for a healthy meal. So we are in a very interesting time with the challenges that are in front of us. Let's see what happened. Yeah, there we go. I think this phrase I have used at other few moments. I read this phrase a number of years ago in a book that Andy Grove wrote. It's only the paranoia that survives. There are moments in history when change is exponential rather than incremental. At such times, all bets are off, and the rules of business, even the grounds of competition, shifts fast, furiously, and forever. We could be at that moment. Thank you for the opportunity.
Yeah, Brahm, thank you very much for those observations. And I'm really pleased that you were able to capture what some of the other speakers have made. We're going into the last part of our program now, and we're really grateful for our keynote speaker. And I'm going to turn it back over to Guru to introduce our keynote speaker. So Guru, go ahead.